Hello everyone, myself Ankur Patel, and today in the second session of projection of planes, we are going to discuss problems of projection of planes by using the basic concepts of projection of planes. So let's start with the first problem today. This is our problem number 4, because in the last session we have discussed the 3 problems of projection of planes. So today we will start with the 4th problem, which is the problem of the pentagonal plane. So a regular pentagonal plane having the side 30 mm is resting on HP on one of its corners. The surface of the plane is inclined to HP at 45 degrees. Draw the projection of the plane when the side opposite to the corner on which it rests on HP is inclined at 30 degrees to VP. So right now here the pentagonal plane is resting on HP and its surface makes an angle of 45 degrees to the horizontal plane. So to derive the first stage, we have to assume the surface of the pentagonal plane parallel to the horizontal plane and perpendicular to the vertical plane. And we have to mark the corner of the pentagonal plane on the left hand side of the drawing. So let's start with the first stage, in which we have to assume the surface of the pentagonal plane parallel to HP, and we have to take the corner on the left hand side because it is resting on corner on the horizontal plane. And here we are going to use the first angle projection method. So we will get the plan of the pentagonal plane below the XY reference line, because we will get the horizontal plane below the XY reference line. And right now the surface of the pentagon is parallel to the horizontal plane. We will get the true shape on the horizontal plane, or true shape of the pentagon on the horizontal plane. So let's start with drawing the pentagon in the true shape in the horizontal plane by taking corner on the left hand side. So this will be our corner A, B, C, D, E. So this will be A, B, C, D, E, and the side of the pentagon is 30 mm, which is given. Now we have to draw the elevation of the pentagonal plane in the first stage. So project A, B, E, C, D up to XY reference line. We will get the elevation of the pentagonal plane in the first stage. So this is A dash, this will be B dash, E dash, and this will be C dash, D dash. Connect these points, we will get the elevation of the pentagonal plane. So right now in the first stage, the top view will show us the true shape, and the elevation will be a line parallel to the XY reference line, because the plane is parallel to the horizontal plane and it is perpendicular to the vertical plane. And whenever the plane is perpendicular to the vertical plane, the elevation of that particular reference plane will be a line. Now we have to derive the second stage. So right now the plane is resting on HP. So in the second stage we have to derive the condition with the horizontal plane, and the condition is given: the surface of the plane is inclined to HP at 45 degrees. So if we want to make the surface inclined at an angle of 45 degree, we have to incline this elevation, that means A dash, B dash, E dash, and C dash, D dash at an angle of 45 degree to the XY reference line by taking A dash on the XY reference line. So redraw this elevation over here at an angle of 45 degree by taking A dash on the XY reference line. Now why we have taken the A dash on the XY reference line? Because it is resting on one of its corner and we have selected corner A. So whenever any corner is on the horizontal plane, or any point is on the horizontal plane, then the elevation of that point will be on the XY reference line, and we have taken the corner A on the horizontal plane. So we will get the elevation of that point on the XY reference line. So we have marked the A dash on the XY reference line. Now mark C dash, D dash over here. The length of this line and this line will remain same, because we have copied this figure over here, but just inclining this figure by at an angle of 45 degree. Now A dash, measure A dash to B dash, E dash, and give an arc over here from A dash. Here we will get B dash, E dash. Now if you want to draw the plan in the second stage, we have to take the projection of A, B, C, D, E on the right hand side. So draw the projections, or we can say that these are the locus of A, B, C, D, and E. Now draw the projector of A, B, C, D, E from the elevation. So here we will get A1, here we will get B1 and E1, and here we will get C1 and D1. Now join these points, we will get the plan in the second stage. This will be our final plan or top view. Now last stage. So in the last stage we will derive the condition with the vertical plane. Now let's see what is given conditions. So draw the projection of the plane when the side opposite to the corner on which it rests on HP is inclined at 30 degree to VP. The side opposite to the corner on which it rests on HP. So right now the pentagon is resting on corner A on the horizontal plane, and the side opposite to this corner is side CD, which makes an angle of 30 degree to the vertical plane. So right now we can say that side CD makes an angle of 30 degree to the vertical plane. So here we have to understand one conditions. Here we will always copy this top view. So for that the angle of inclination of the top view should be beta. But right now it is given that the side opposite to the corner, not the plan of the side opposite to the corner. So right now the given angle is angle phi. So it is required to find out the angle beta. Now if you see that the true length of side CD and the plan length of side CD will remain same and both are equal. So we can say that right now the phi angle is equal to the beta angle. So right now we can say that this 30 degree angle is the phi or beta angle, and we have to copy this figure. So for that we have to find out the beta angle for C1 and D1, and right now the true length of CD and plan length of CD will remain same. So we can say that right now this angle is the beta angle. So now we have to copy this figure over here by taking C1 D1 at an angle of 30 degree, or by inclining C1 D1 at an angle of 30 degree. So copy this figure over here by taking C1 D1 on this line, which is inclined at an angle of 30 degree to the XY reference line. So this will be our top view again, and we have to give the numbering like this C1 D1, C1 D1. So here we will get B1, here we will get A1, and here we will get E1. So this is our top view. These both figures will remain same because we have to copy this figure over here, but just inclining the C1 D1 at an angle of 30 degree. And right now this 30 degree angle is phi and beta both, because true length of CD is equal to the plan length of the CD, and we have to always copy the plan over here. Now we have to draw the elevation. For that draw the projection from here A, B, C, D, E. So draw the projections. This is the projection of this is the locus of C and D, this is the locus of B and E, and the XY line will be a locus of A. Now project these points vertically upwards. So here we will get A1 dash, B1 dash, C1 dash, D1 dash, and this will be our E1 dash. Now join these points A1 B1 dash, C1 B1 dash, C1 dash, C1 dash D1 dash, D1 dash D1 dash, and E1 dash to A1 dash. We will get the front view of the pentagon. So these are our final top view and front view. This is the apparent shape that we will observe from the front direction. Now let's move on to next example. An isosceles triangular plate ABC having its base 50 mm and altitude 90 mm is resting on HP on its base. So right now again the plane is resting on the HP. The isosceles triangle is inclined at an angle of 40 degree to the horizontal plane, and the altitude is inclined at an angle of 30 degree to the vertical plane. Draw the projections. So let's start by drawing the XY reference line, and in the first stage, as the isosceles triangle is resting on the horizontal plane, we have to assume the isosceles triangle plane parallel to the horizontal plane in the first stage and perpendicular to the vertical plane. So let's try, and here right now the isosceles triangle is resting on its base, so we have to show the base on the left hand side of the drawing. So assume surface parallel to HP by taking base on the left hand side. So draw isosceles triangle having base 50 mm and altitude 90 mm. So this will be our altitude. A line connecting this corner and the center of the base is known as the altitude. So this is our ABC isosceles triangle, and OC will be our altitude, which is 90 mm. Now we have to draw the elevation. So project these points upwards. Here we will get A dash, B dash, here we will get C dash, and this will be our elevation, which is a line, and the top view will be a true shape. Now in the second step we have to derive the condition with the horizontal plane, because the plane is resting on HP, and here it is given that the isosceles triangle is inclined at an angle of 40 degrees to the horizontal plane. That means the surface of the triangle is inclined at an angle of 40 degrees to the HP. So for that, now we have to incline this elevation A dash B dash C dash at an angle of 40 degrees to the XY reference line by taking A dash B dash on the XY reference line. So incline this elevation at an angle of 40 degrees to the XY reference line by taking A dash B dash on the XY reference line, because right now the triangle is resting on its base and base is AB, so the elevation of the base should remain on the XY reference line. So this is A dash B dash, and this will be our C dash at the same distance from A dash B dash to C dash. Now if you want to draw the plan when the surface is inclined at an angle of 40 degree, so first of all we have to draw the locus of A, C and B from the first stage, or from the plan of the front stage, and then after we have to take the projector of ABC from the elevation. So draw the projections. Here we will get A1 B1, here we will get C1, and connect this A1 B1 C1. We will get the plan in the second stage. This is our final top view. This will be our plan of the altitude, which is O1 C1. This is our altitude, so OC will be our altitude and O1 C1 will be the plan of the altitude. Now let's derive the last stage, in which we have to derive the condition with the vertical plane. So let's see what is given. So here it is given that, and the altitude is inclined at an angle of 30 degrees to V. Draw the projections, and just we have discussed that this is the altitude, that means OC is the altitude and O1 C1 is the plan of the top view of the altitude. So we have to make altitude incline at an angle of 30 degrees. So here we will take OC, but as we have discussed earlier, we will always copy this figure over here. So for that we have to find out the beta angle for the plan of the altitude, because here the angle of the altitude is given. So here we have taken altitude OC. Now measure O1 C1. If you want to find out the angle beta for O1 C1, measure O1 C1 on the rounder, take center end O and give an arc on locus of C. This will be our locus of C. Connect these lines. This is O1 C1. This will be our angle beta. Now copy this figure over here. So here we will get A1 B1, and here we will get C1. So this is the top view of the isosceles triangle, plan of the altitude incline at an angle of beta. Now we have to find out the elevation. So to find out the elevation, first of all draw locus of A, B, C from the elevation. So this will be locus of C, and the XY line will be locus of A and B. Now project these points A1 B1 C1. So here we will get A1 dash, here we will get B1 dash, and here we will get C1 dash. Connect these points A1 dash to B1 dash, B1 dash to C1 dash, and C1 dash to A1 dash. We will get the final front view, and this is our apparent view. Now let's move on to next example. A circular plate of negligible thickness and 46 mm diameter appears as an ellipse in the top view, having its major axis 46 mm long and minor axis 28 mm long. Draw the front view when the major axis of an ellipse makes an angle of 60 degrees to VP. So first of all draw XY reference line. Now here the resting condition of the plane is not given, but here it is given that the top view appears as an ellipse. So having major axis 46 mm and minor axis 28 mm. So from this statement we can say that the plane will rest on HP. So in the first stage we have to assume the surface of the circular plate parallel to the horizontal plane. So if we assume the surface parallel to the horizontal plane, we will get the true shape on the horizontal plane or below the xy reference line. So below the xy reference line, first of all draw a circle having diameter 46 mm. So draw a circle having diameter 46 mm. Now divide the circle into 8 equal parts. So divide it into 8 equal parts. Mark the points. This is A, B, C, D, E, F, G, H. Now if you want to draw the elevation of this plane, we project all the points on the xy reference line. So here we will get A dash, here we will get B dash H dash, here we will get G dash C dash, here we will get D dash F dash, and here we will get E dash. So this is A dash, B dash H dash, C dash G dash, D dash F dash, and E dash. Connect these points, we will get the elevation. And right now the elevation is a line because the surface of the circle is parallel to the horizontal plane and it is perpendicular to the vertical plane. And whenever the plane is perpendicular to the vertical plane, the elevation of that plane will be a line. Now we have to derive the second stage. Now here the inclination in the second stage or inclination with the horizontal plane in the second stage is not given, but it is indirectly given in terms of the top view of the circular plane. So here it is given that it appears as an ellipse in the top view, having its major axis 46 mm long and minor axis 8 mm long. So here in the top view we have to draw the ellipse having major axis 46 mm, minor axis 20 mm. So first of all project these points AE and GC. Now you can see that the length of this diameter of the circle doesn't change in the plan of the circle. So the GC length will remain same. So we will consider this GC diameter of the circle as the major axis of an ellipse. So this will be the major axis of the ellipse, and now we have to draw the minor axis having length equal to 28 mm. So these are our minor axis having length equal to 28 mm, and make sure that the major axis and minor axis should be perpendicular bisector of each other. So this will be our A1 E1 and this is G1 C1. So G1 C1 will be our major axis of the ellipse and A1 E1 will be the minor axis of the ellipse. So the length of the major axis is equal to the diameter of the circle and length of the minor axis will be equal to 28 mm. Now project these points upwards. Here we will get A dash. Project these points upwards. Now measure A dash to E dash on the rounder, and by taking center at A dash give an arc on this projector of E dash. Here we will get E dash. Connect this line A dash E dash. Now project this point GC upwards. Here we will get C dash G dash. Now measure A dash to B dash H dash and give an arc over here. Here we will get B dash H dash. Measure A dash to D dash F dash and give an arc on this line. Here we will get D dash F dash. Mark these points B dash H dash and D dash F dash. Now project these points vertically downwards. Here on this projector we will get B and H, and on this projector we will get D and F. Now draw the locus of HF from over here and BD over here. So this is our B1, D1, F1, H1. Now draw the freehand curve passing through these points. We will get the ellipse having major axis 48 mm and minor axis 28 mm. Now we have to derive the third stage. So in the third stage we have to derive the condition with the vertical plane. Now let's see what is given for the vertical plane. So draw its front view when the major axis of an ellipse makes an angle of 60 degrees to B. Major axis of an ellipse. So what are the major axis of an ellipse? Yes, it is G1 C1. So right now the angle given is a beta angle for GC, that means for G1 C1. So right now we can directly draw this figure over here without finding the beta angle because the given angle is the beta angle. It is the angle of for G1 C1. So draw a line inclined at an angle of 60 degree to the XY reference line, and on this line we have to mark G1 and C1. So mark G1 and C1, measuring it from this figure. So this is our G1 and C1, and now from the midpoint of G1 and C1 draw a line perpendicular to G1 C1 over here. So here we will get A1 E1. Now we have to find H1 B1 D1 and F1. So for that draw this rectangle by measuring it from the top view in the second stage. Draw this rectangle at the given particular distance. over here. So here we will get P1, D1, F1 and H1. Now again draw the freehand curve passing through these points. We will get the top view inclined at an angle of 60 degree, or we will get the top view of the ellipse with major axis inclined at an angle of 60 degree. Now we have to draw the front view. So if you want to draw the front view, first of all draw the locus of A to E, that is locus of E, DF, GC, BH and A. So our locus of A will remain on the XY reference line. Now project these points upwards. So here we will get A1 dash, here we will get B1 dash, here we will get C1 dash, here we will get D1 dash, E1 dash, F1 dash, G1 dash and H1 dash. And now draw the freehand curve passing through these points. We will get the final front view, which is our apparent shape. Now let's move on to next example. An elliptical plane with major axis 70 mm and minor axis 50 mm is inclined to HP such that the top view of the plane is a circle. Draw the projection of the plane when the major axis is inclined at 30 degree to the vertical plane. Find the inclination of the plane with the horizontal plane. Use the concentric circle method to draw the top view of the plane in the initial stage. So first of all draw the XY reference line, and here the plane is inclined to HP. So the surface of the plane is inclined to the horizontal plane. That means in the first stage we have to assume the elliptical plane or the surface of the elliptical plane parallel to the horizontal plane and perpendicular to the vertical plane. And in the initial stage we have to draw the ellipse by the concentric circle method that we have discussed in engineering course, but let us discuss it again. So in the first stage below the XY reference line we have to draw the ellipse by using the concentric circle method. So first of all draw the major axis. Major axis of the ellipse is 70 mm and the minor axis of the ellipse are 50 mm, and major axis and minor axis are the perpendicular bisector of each other. So this is our AE. So AE will be our major axis and GC will be our minor axis. Now let us apply the concentric circle method. So concentric circle method, that means the circles having the same center. So here we have to draw the concentric circles. So the radius of the first circle will be half of the major axis. So by taking center at the intersection point of the major axis and minor axis, draw one circle having radius is equal to half of the major axis, and again by taking the center over here, draw another circle having radius is equal to half of the major axis. So draw another circle having radius or diameter equal to the major axis. So after drawing these circles, now divide the circles into 8 equal parts. Now after dividing the circle into 8 equal parts, from the points of the outside circle 1, 2, 3, 4, we have to draw lines parallel to the minor axis, that is parallel to GC. So draw lines parallel to GC from the points of the outside circle. So from this point, this point, this point and this point, draw lines parallel to the minor axis. And from the points of the inside circle, draw lines parallel to the major axis. So from this point, this point, this point and this point, draw line parallel to the major axis. Now mark the intersection point of this horizontal line and vertical line. So this is our B, D, F, H. Now draw the curve passing through these points. We will get the ellipse. So this is the ellipse by the concentric circle method. Now we have to draw the projection of this ellipse. So first of all we have to draw the elevation. So for that, project point A, B, C, D, E, F, G, H vertically upwards. So here we will get A dash, here we will get H dash B dash, here we will get C dash G dash, here we will get D dash F dash, and here we will get E dash. Now connect these points, we will get the elevation of the ellipse, and it will be a line because in the first stage we have assumed the surface of the ellipse parallel to the horizontal plane and perpendicular to the vertical plane. Now we have to derive the second stage, and in the second stage we have to derive the condition with the horizontal plane. but here the condition with the horizontal plane, that means the angle of inclination with the horizontal plane, is not given, but indirectly it is given in terms of the plan. So here it is given that the plan or top view of the plane is seen as a circle. So now we have to draw a circle. So before drawing the circle, first of all project AE and GC. Now if you want to draw the circle, the diameter of the circle will remains equal to the length of the minor axis. So the length of the diameter of the circle will be equal to the minor axis. Now taking center over here, draw a circle. This will be our plan, and divide the circle into 8 equal parts. We will get A1, B1, C1, D1, E1, F1, G1 and H1. Now project this A1 over here. Here we will get A dash, E1, and now measure A dash to E dash. Take center at A dash over here and give an arc over here. So here we will get E dash, connect A dash to E dash. Now mark all these points on this line by measuring it from A dash. So mark these points. This will be B dash, H dash. You can also mark these points by projecting it from the top view. Here we will get C dash, G dash. Here we will get D dash, F dash. Now here it is given that find the inclination plane with the horizontal plane. So this will be the angle of inclination of the surface of the elliptical plane with the horizontal plane. So measure it by using the protractor. It will be equal to 44 degree. Now let's derive the third stage. So let us see what is the condition given for the third stage, and in the third stage we have to derive the condition with the vertical plane. So let's see what is the condition with the vertical plane. So here it is given that draw the projections of the plane when the major axis is inclined at 30 degree to the vertical plane. So what are the major axes of the ellipse? Yes, AE. So right now AE makes an angle of 30 degree to the vertical plane. So draw a line inclined at an angle of 30 degree to the XY reference line, and on this XY reference on this line we have to mark AE, which are the major axis. So mark major axis. Now as we know that always we have to draw the plan, or we have to copy the plan over here. So we will find the beta angle for A1 E1, because right now the angle of AE is given, that is our true length. So we have to find out the angle for A1 E1, which is our plan length. So now measure A1 E1, take center at A and give an arc on this locus. Here we will get E1, and this will be our A1. Connect these points. This will be our plan of the major axis, which will be the diameter of this circle. This will be our beta angle. Now mark the center of the circle on A1 E1. So on A1 E1 mark the center over here and draw the circle having radius is equal to 25 mm, because the diameter of the circle is 50 mm, which is the length of the minor axis. So draw a circle having radius is equal to 25 mm, and mark all these points over here again by dividing the circle into 8 equal parts. Divide the circle into 8 equal parts, mark all the points A1, B1, C1, D1, E1, F1, G1 and H1. Now we have to draw the elevation. So if you want to draw the elevation, first of all draw the locus of A, B, C, D, E, F, G and H. So draw the locus. This is locus of E, this is locus of D and F, this is locus of C and G, this will be locus of B and H, and this will be the locus of A. Now project these points. This will be our A1 dash, this will be our B1 dash, this will be our C1 dash, this will be our D1 dash, this will be our E1 dash, this will be our F1 dash, this will be our G1 dash, and this will be our H1 dash. Now draw the freehand curve passing through these points. We will get the final front view. So draw the freehand curve passing through these points. We will get the final front view, and it is an ellipse. So this is it for today. Thank you for watching. We will come with some more problems of projection of planes in our next lecture. Till then, take care.